z component. Okay, but the total representation for any vector, when we are representing it, as I mentioned before, axi like a dyj plus dzk. Ax, dy, dz, these are components along those particular axes, and I, j, and k, these are unit vectors along those directions. Let's do this problem, and I think this will clarify what I said about that. Determine resultant vector of the following vectors. So A, you have two components. B, you also have two components. For C, you also have one component. Look at this. You have I and j for the A and B, but here for the C, you have only j. And when you are adding them, since they are saying determine the resultant vector of the following three vectors. So when you are adding them A plus B plus C, what will be strategy? The strategy is going to be you are adding the x component with the x component. And for the C, the x component is 0. So therefore, you are adding nothing from the C for the x component. For the j component, you have this component of ax, b, and for the C as well. So this is like the Rx. We have this. The sum of all three is 2.6 meter. And similarly, we have the y component. So the sum of the three components is coming out to be minus 2.3 meter. So since we are interested in knowing the resultant vector, so therefore we are putting this Rxi and Ryj. So you keep the same signs, whatever the signs appears, okay? So if it was positive sign, you keep positive sign. If it was negative sign, you keep the negative sign. So what you see here, this vector in the answer, this will be called representation of the vector in unit vectors. Okay, so this is the unit vector notation we used for representing a resultant vector. Similarly, for the initial vectors, these are also the unit vectors notation. So that's what the language we will be using for it in the coming chapters. Here is a checkpoint, and I want you to participate in this. There we have two vectors. One is d1 and another one is d2. These are the two vectors we are dealing with here. That's shown in the right side diagram. And what we are going to do, what are the signs of the x components of d1 and d2? So if I ask you here, what are the signs for the x component of d1? What will be your answer? Is it positive or negative?
Positive.
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 Okay. And how about for the x component of d2?
Also
Negative.
X component is positive because it still extends in the positive x direction like this way. Right?
Y is negative.
Yeah. When we go towards y, so you know that for the d1, the y is going in this direction, which is the increasing direction of z. And if you look at the d2, this is coming in the decreasing direction of d, right? So therefore, the y component for the d2 is negative. So when I'm sketching the resultant vector, which will be from this origin to this tip of the last vector, what do you expect about the x and y components of that? What will be the sign of that?
positive.
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 Yeah. Okay. So this is what we have, right? And you correctly answered. Now there is another way of looking at things. Okay. So sometimes, whenever you are looking going in a plane and you are piloting a plane, let's say, so all the things which you are seeing them, since the plane, when you are looking in the front window, all the things will appear to you with respect to the dashboard in front of you, right? So if you are taking the turn in the airplane, then your dashboard will be vertical in that situation, and then you are looking with respect to that. So along those all alternations, all the rotations which you are making, you are referencing something with respect to your dashboard. So it is another way of looking at things. Okay, so whenever you are looking something and associating that with your dashboard of your plane, and all the time your plane is rotating in one way or another, then we can also say that this is the rotation of the axis, because every time I'm looking at things with respect to a little bit inclined plane. So actually I changed my X and Y orientation a little bit. So if I keep the X-axis always parallel to my dashboard of the plane and the Y component perpendicular to me, so if I'm having a little bit turn, then you will be seeing that the X component will come towards sky and the Y component will be parallel to the land in that sense. So that is the representation of vectors. So here when we are doing this, we are saying this freedom of choosing a coordinate system. So you are free to choose however your mind is perceiving the information, you are free to choose in that. But what will be the effect of that ultimately? So this is the normal situation in which we are representing X and Y components. So here you have vector A, and this is X and Y components of that. And this is a little bit inverted, like your plane is now inverted and this is along your dashboard. Initially, this was the dashboard. This is now the next dashboard, right? So here, with respect to that, since the X and Y are always going to make 90-degree with respect to each other, so if your dashboard turned by 15 degrees, so your Y will also move by 15 degrees. And if this was some reference point for you, initially here, which is vector A, here in the same inverted coordinates, the reference point is also the same. You are free to choose coordinate system, but you cannot have the authority to change the entire landscape. So the landscape which you are observing, it is always in the same way. Okay, so this is from A to B. This is the another vector. Now what will happen? Well, if I look at something with the inverted orientation, well, the dimensions of that thing will change. Okay, logically we say no. And the mathematics, when we are doing this, it always tells us no. Because ax, which is the x component of the vector a, ay is the y component of the vector a, and when we're looking for the magnitude of vector a, it can be seen as ax squared plus ay squared under square root. So that's how I get the magnitude of this vector. If I go for the y vector in the inverted rotations, it is going to be ax prime. This is one component. Ay prime is another component. And when I look at the ax prime square plus ay prime square and take the square root of that, I will get the same magnitude. So what is different? Well, the difference is in the x component. You see here the x component is a little bit small, and here the x component of this vector is large. And other way around, if you look at that, the y component here was large and the y component here is small. So individually, x and y component with respect to your rotated coordinates can be different. But when you look at the total magnitude of the vector, it always be the same. That's the conclusion of this topic. Okay, so do you have any quick question? I can take a question and then we go to the multiplication. Any quick question regarding the rotated coordinates or the unit vector notation? Okay.
The rule, the theta rule under. What is the name of the sign?
This is theta and this is pi. This is called pi, P-H-I, pi.
Phi. Okay, thank you.
Yeah. Okay. So here when we are coming towards the multiplication of vectors, and then we have three different kinds of multiplication. One, if you choose any vector and you multiply that with a constant vector, with a constant scalar quantity, you can do so, and all it will do, it will change the magnitude of the vector by that much. Let's say you have vector A and you multiply that with the 2. What you will get, let's say this is your vector A and you multiply this with 2. What you will get, the length of the vector is going to be double because you multiplied it with 2 times. But if you look at the direction will remain the same. It has no effect on the direction. And also you see this q, which is represented here as a general quantity. You can represent q, which is a scalar, either by the cross or by this way. Both ways are fine. But since there is not carrying any vector sign on it, So therefore, it is perceived as a scalar quantity. Okay. Now, if you multiply the same vector by 3, all we are going to do is change the length of the vector by 3 times. The direction still remains the same. So no matter what quantity you use for this multiplication, all you are going to do is to change the magnitude of the vector by that quantity. There is nothing special here. Okay. Now, when it comes to the other multiplication, one is called dot product, another one is called cross product. So for the dot product and the cross product, we have two different scenario, and both of them, this one also has a physical meaning. This one has, like, if you have represent a force, which is a vector quantity by by vector A, and you multiply that with the 2, so it means that you increase the force by 2 times. So there is a physical meaning for this. But here, when you are looking for this scenario, dot product, since at this stage I'm assuming that you are not familiar with the dot product or the cross product or the depth meaning of this, but the dot product, when you make it, the end quantity which you get after the product, it will be scalar. Okay, so the dot product is also called scalar product. These two are alternative names for it. If someone asks you to determine the scalar product of this, or says determine the dot product of this, both of these quantities will be the same. So here you have vector A and you have vector B. You are taking the dot product of this. So the algebraic formula for that is AB cosine theta. So the theta or the pi is here. So A dot B equal to AB cosine pi. Here AB, which is on the right side, these are the magnitudes of the two vectors. So for the vector A is the magnitude. For vector B, B is the magnitude. Cosine pi is always the angle between vector A and vector B. Okay, and it doesn't matter here in this case, especially in the dot product. It doesn't matter where you are taking this from A to B or from B to A. Okay, whether you are taking the direction of the theta or the pi from A to B or from B to A. But it will definitely matter when you are talking about the cross product. And the reason is here the cosine theta, because cosine is an even function. Okay, this is the another representation of this. For the same vectors, if I'm representing a b cosine theta, then you see that if I remove this b to a little bit to the side, what you will see is that I will be seeing a cosine pi times b. So you know the a cosine pi is the x component of vector A, right? So here, when I come here and I look at this product, I extend and assign the components to vector A. So you know the vector A has x component, which is ax here and ay here. Okay, so ax of A is along vector B, and here we are assuming this vector B is similar to x-axis, like what we used to use. Okay, so ax, which is a cosine theta times b, is going to give us the scalar product, and it will be also seen as the component of vector A along the direction of b. This can also be seen in that. Another way of looking at this, you can take a common of it and see this as a b cosine theta. When you write this as a b cosine theta, what you will see is that it is the x component of the vector b. So here, when you look at the x component, this is that one, and times a, when you get, it will also give you the same quantity. But you know that ab cosine theta, it doesn't carry any units, so it doesn't matter which x component you are considering, either from A or from the B, but at the end, the answer is going to be the same. Okay. And the application of this, you will see in the work, like if this was the force, okay, this was the force, and this is the displacement in which you are pushing some objects, like this is a box and you're applying your force to it. And the box covered a displacement d along the direction of the force. So when you get it will be the quantity, their quantity will be called the work, which will be FD cosine theta. So that's the implication of that. And quite rightly, like in our normal language, whenever someone do some work, we are not saying in which direction you did the work, either up or down or this and that. We are not concerned about the direction in the terms of the work. And that's why, because the sense of that is scalar, dot. Okay, here is a checkpoint, and again, your participation is needed here. Vectors C and D have magnitudes of 3 units and 4 units, respectively. What is the angle between the directions of C and D if C dot D equals 0, 12 units, and minus 12 units? So the hint for that answer is I already provided here. C dot D is equal to CD cosine pi. And you are looking for the angle, what is going to be the angle here? So you divide both sides by CD and then take the inverse of cosine. So this will be the pi equal to cosine inverse of C dot D divided by CD. This is one thing, how you are going to determine this. But if the product was equal to 0, what should be the angle here between C and D?
90.
90 degree, yes.
9.
Exactly, because the cosine for 90 is 0. And if it was 12, what is the angle here?
0.
0.
The angle is 0, yes, because the cosine for 0 is 1, and all you are going to do is the 3 times 4, it will be 12. So it is understood now. The last part is going to be, since it's minus 12, so you are demanding the cosine theta to give you minus 1, which it will give you by choosing the pi equal to 180. So cosine 180 is equal to minus 1. Okay. Here we are coming towards the cross product. This is the another product which we will be concerning in this chapter. So there are two names for this, like same was for the scalar or the dot product. So there were two names for that: scalar product and dot product. Here, when we are looking for this kind of product, and it is represented by the cross. So just because of this representation, we are calling it cross product of the vectors. But here, we are also calling it a vector product because when we make the product A cross B, the answer which I get on the right side, it is a vector quantity. In the dot product, the answer which I get on the right side, like the C D cosine theta, this is a scalar quantity. There is no sense of direction afterward. But here, when I get something out of this, which is again a vector, and there's a sense of direction associated with that. Okay, so A cross B, it gives me A, B, sine theta, and then the unit vector n. So that unit vector n, we are going to work on that, how that is going to be. And in this one, let me take you back. This product, C dot D, it does not matter. Either you multiplied C with the D or D with the C. Means if you change the order of the C and D, the answer is going to be again the same, C D cosine theta. It doesn't matter here. The change of the order doesn't matter. While here, if you change the order, A cross B, it gives you one kind of answer. If you make the product of B cross A, it is going to give you another kind of answer. Okay, and these two I'm going to explain. I will be also showing you the right hand rule here. So for this, the result is a new vector, which is vector C, and the magnitude of that is going to be AB sine pi. Here A and B are magnitudes of the vector A and B respectively, and pi is the angle between them. Okay. And one thing which is quite said it a little bit subdued, but let me emphasize here this point here. Pi is the smaller angle between A and B. The smaller angle means here. Come here. When you are making any product between the two vectors, and this angle is going to be from A to B or from B to A, which we are taking, it should be the smaller angle, not this angle. You also have the choice to choose this angle. So that's why the smaller angle uh, word is emphasized there. Here, this is a very important rule we need to practice here. As normally in class, I teach this rule a little bit in different variation of this, but now we are talking about just this this voice interface. So it's almost like a radio. So you are not seeing my a lot of my signs. So therefore, I will be sticking with whatever I'm describing here in the slides. So when you are looking at the right hand rule, what you have that if you put your hand like that, like just straight line hand, and then make this thumb such that it makes 90-degree with respect to your rest of the fingers. So this is your right hand rule. Okay. Now what you will do is that if your vector A is going to give you the direction along A, okay, you are putting the vector, the direction along the direction of A along the thumb, okay, this is the thumb, and you put the direction of B along the direction of your four fingers here, okay. Then these are the two directions, and when you make the multiplication, you are going to get the third vector, which will be just out of your palm, outside. If we are seeing my video, it will be towards you like this, okay? Generally, what I teach the variation of that like this. These three fingers like this, one finger up and thumb like that, okay? So all the time, whenever you multiply, let's say this was my vector A along this finger, and this is my vector B along these three fingers, which I have curled like straightened like this, okay? So the direction of the resultant vector, which is vector C, it will be always towards my thumb C, okay? So that is going to be the process in which we are going to do. Another thing is, assume that you have vector A and vector B represented along X and Y axes, okay, X and Y coordinates. So that's the two-dimensional section in which you represented it, okay? Now, when you multiply A with the B, the resultant vector which you get, it will be outside of that page. So that will be definitely along Z direction. So that could be either along minus Z direction or plus Z direction, depending on which vector you multiplied first. Either that was A cross B or B cross A. Okay, so which I mentioned, the A cross B and B cross A makes a difference. The difference is coming just because of the direction. Okay, so it will be even clear here.
Doctor,
Yes.
can I say that the result of cross product is a new product that is perpendicular to the products, two vectors?
Yes, it is. It is correctly this. This exactly what I wanted to say. So when you have two vectors, vector A and vector B, if this was represented in XY direction, so which is the one plane, like the wall of your room, and when you are taking the cross product of them, the vector which you get, which will be vector C, that will be outside of the wall. So that will be either this way or that way. The direction of that now measures whether you multiply A with the B or B with the A. So which one comes first, accordingly, it will change. And you can see, quite rightly see in this diagram here, like when we are making the right-hand rule, then you will see the direction. Either you multiply A with the B, like if this was going this way, then you are having the thumb out of the page. If they were coming this way, then you will have to change your thumb to the other direction. This is the cross product. How many of you are familiar with the matrices and determinants in mathematics? Did you do determinants?
Yes.
Okay. And when you have a determinant of three quantities, there are three rows in your determinant, right? And you are making the product of that. So you keep I like A11, you keep that constant and you multiply this with the A12 with the 2 with the 3, right? So that's the cross zigzag cross you are making the product. So this is the determinant product which we are seeing here, uh, but that is not shown here because the assumption was that the determinant might be not known to a lot of students here. So let me go over these vector products here. When you have vector A and vector B, and both of them are completely uh, three-dimensional vectors, okay? So here, when you are making the product of A with the B, so AX, BX, and now you see that the vector here, which is vector I, you are taking the cross product here with the vector I. So since these two vectors, I times I, they are the same vectors, right? One is along x-axis, another one is also along x-axis. So I cross I, the angle between them is 0. And what do you get when you put sine 0? What is the answer?
0.
0. So therefore, whenever when you are making the cross product of the same components, it will always be 0. Now, the second component, when you are making the AX with BY, so AX BY, that's what we got. And now we are making the cross product I with the J. So I cross J. So when I make the I cross J, what I will get, it will give me the vector K because the I is along x-axis, J is along y-axis. So when I use my fingers, just look at in the values here. If I put this finger along these fingers along the direction of x, right, and this palm along the direction of y, okay, by default you see that this finger is going to be towards Z, which is out of the page here, okay? Or if you're going with my method, then this is another method that which I'm using. Whichever you are comfortable with, just keep using that and stick with that one method, okay? So I cross J is going to give you K, and I cross K is going to give you what it will give you. I cross K.
J. J.
Will it give us J or it will be minus J?
Either.
Not either. If we are making it I cross K, then it is going to give us minus J, okay? Because when you put again your finger along this finger along the Z direction, I put it there, okay, which is the K. Let's put it this way, and this is here. If I put this along I and this is along Z, then you see that the thumb is going to be downward, which is the negative y direction. So therefore, we are getting the minus J out of that. So I think you got this idea that if you are having again J cross I, then it is going to give you K, right? But it is not K. It is going to give you minus K, J cross I. So I'm going to sum up this in the next slide. What is it means here? Whenever for the cross product, whenever you are taking the cross product between the same vectors I, j, k, it will always be 0. Okay. Whenever you are taking in the cyclic order, you know naturally after I there is come j, after j there is come k, and after k there will be again you are coming back towards I. If it was coming in that order, I was first, J was after, and then similarly the other way. If that was the case, then you will always get a positive quantity here. But if the order was reversed, you will get a negative quantity. Like this, I cross J, you got the K, which is the third vector of them, okay? Similarly, if you have J cross I, you see the order is changed. Instead of I cross J, you have J cross I. So the order is changed, therefore you have negative K. Just look at this difference. So if you go from I to J, J to K, K to I, you will get positive quantities. And it will always be the third vector which was not there. Okay. But if you go in the opposite direction, from the I to K, like you skipped something in between, or you think that the order is completely reversed, you should be going from K to I, but instead of that, you come from I to K. So if that is the order, then you will always get negative quantities like here, as well as here. This for the cross product. For the dot product, which we did the scalar product in the previous slide, since you know that A dot B is equal to AB cosine theta, so there is a nature of cosine theta involved. So whenever you have multiplied the same vector with the same, that the angle between them is going to be 0. So you know the cosine for them is 1. Cosine 0 is 1. So I dot I is 1. So the same vectors between the same components, the product between the same components will always give you 1, 1, 1. And you know the cosine 90 is 0. So therefore, all the odd vectors, which are not the same vectors, they will give you 0. So this is the final conclusion for the. This is another checkpoint here. Vectors C and D have magnitudes of 3 units and 4 units respectively. What is the angle between the directions of C and D if the magnitudes of the vector product C cross D is 0 and 12? So it is very connected to the similar to the checkpoint 4, but now we are looking for the two choices here. We are looking for the magnitude of C cross B. If it was 0, what do you think? What is the angle here?
0.
Okay, and if it was 12, what is the angle then?
90.
90. Yeah. So these are the two choices we have. And if it was minus 12, they ask, like similar to checkpoint 4, then the angle is going to be 270 because sine 270 is minus 1. Okay, so this problem here, this will clarify some of your questions regarding the vector product, like how this vector product is going to give us a third vector, which will be perpendicular to the first two vectors. So carefully read the language of this problem because it's a little bit confusing. In this figure, vector A lies in the xy plane, has a magnitude of 18 units and points in the direction 250 degrees from the positive direction of the x-axis. Okay, so vector A, it is making 250 degree with respect to x-axis. So look at this. First of all, this is the x-axis and this is the positive y here, positive x and positive y. So vector A is going to make this 250 degree all the way from here to here, and this is the direction of the vector now. And it has the magnitude of 18 units. Also, vector B has a magnitude of 12 units and points in the positive direction of Z. So vector B is in the Z direction here, and the magnitude of that is 12. What do you think? What is the angle between A and B? How much an angle it makes?
90.
90 degree, because vector A is in the xy plane and vector Z is perpendicular to that along the Z direction. So therefore, angle between A and B is 90 degree. Now, when you make the product, is they are asking for what is the vector product C A cross B. So what that vector is going to be. So we know that the vector product is going to be AB sine pi, which is like this. AB sine pi, this is the magnitude, 18, 12, and sine 90 because the angle between them is 90. So the answer we got is 216. So 216 is the answer for the magnitude. But what will be the direction? This is without any efforts. First of all, you can determine it where this vector is going to be. So again, I'm using this right hand rule here. Okay, so I put these fingers along the direction of vector A. This palm is pointed in the direction of the vector B. Okay, this thumb is giving me the direction of vector C. And you know that this vector A and vector B in this orientation is telling me that the vector C is making an angle with the vector A is going to be 90 between them. So once we know that the angle between vector A and vector C is 90, and vector A was making 250 angle with respect to x-axis. So what I will do is that 250 minus 90 is going to be the angle of vector C. That's how I'm going to get the direction. Any question here? Okay. So this is another problem, sample problem, vector product, unit vector notation. So it goes again to the cross product here. And luckily there are two components. So whenever we see two components in the vector and they are asking for the cross product, it's a lot easier as compared to the three components. So vector A, it has first component, second component, 3 and 4, and vector B has two components, -2 and 3. These are the components. And when I'm taking the cross product of them, so first of all, I need to put this vector A here and the values of vector B here, and then take the cross product, okay? So the way in which this example is proceeding, that they are making the product of each component with every other component, like a 3i here, a cross with this, and this 3i cross with the 3k. Again, you are proceeding with the j. So from the j with the first component of vector b, and then with the second component of vector b. So from here, we know that I cross I, we know it is going to give us 0, because for the obvious reason, the angle between I and I is 0. But from the I to k, what I'm going to get minus j, right? 3 times 3, I'm getting 9. And from I to k, I'm getting k, j. Similarly, the magnitude 2 times 4, it's 8, but j times a. Now the order is changed, so j times I is going to give me minus k. That's what I'm getting from there. And 4 times 3 is 12, but the j cross k, when I'm making this cross product, in this case, I am going to get I, because it's naturally in the same flow. So plus I am getting from there. So that's how the answer I got here. Okay. Do you have any question here in this problem?
I have question.
Yes.
If we use the determinants in this problem,
Yeah.
the answer will be the same?
Yeah, exactly. That's the best way to use determinant. If you can use them, you will see that when I'm solving the recitation problems, you will be seeing that I will be practicing on the determinants as well, because that's a shortcut for making the cross products. Yeah.
Okay, thank you.
Yeah. But here I'm just going over this method as well, so that students learn this one as well as determinant, and then whichever method they choose for their solutions, they can go with them. Here, this is one of the problem which appeared in a major 1 exam, term 151. A vector in xy plane has a magnitude of 25, and the magnitude of its x component is 12. Okay. Now, the angle this vector makes with the positive y-axis that's what we need to determine. Okay. So a vector in the xy plane has a magnitude of 25. That's one thing is sure. Let's say vector A, and it has a magnitude 25. And its x component is 12, right? So the angle this vector makes with respect to the positive y-axis, this is something which we need to determine. Okay. Now, look at this one. What we did here, that we started from the AX definition. AX is equal to A cosine pi. I was not finding this symbol in my Word file, so I just used the pi here. But otherwise use the correct symbol here. And the AX is equal to 12. That's what they are giving us. The X component is equal to 12, and the magnitude is 25. So you are putting 25 right there, equal to cosine pi. And then this is called psi. Okay, this is psi and this is pi, but you can stick with one name, yeah. And then you are looking to determine this side, okay, angle like the cosine inverse. That's what you used to do. After that, once you do this, recall that you are using the method in the triangles. If I ask you, this is the one vector, you see this diagram here. If this is vector A, and this is the AX here, and this is the AY here, and this is the AY, you know that this side is already 90. What is the sum of all three angles for a triangle?
180.
Right.
Okay, so 180 you have, and you subtract 90 all because it is right angle triangle, so this is one you determine. Here, when you determine this, the angle that it makes with the X component, which is 61, okay, like this, and they are asking what this vector is making this angle with respect to Y. So obviously the choice left for you is 90, because that's what you left with, minus 61.3. That's what you did. And then you will determine this angle, which is this angle here, with respect to Y, between the X and Y components. Sorry, the vector and the Y components. This is a addition. Do you really want me to go over this problem, guys?
No.
Okay, because
No.
this is addition. It's a quite it's just very simple, straightforward. Everything is right there, but it's lengthy. So just read it, and if you have specific question, ask me that, and I will be happy to explain that point. Okay, this is again the major one exam problem, term 151. This has appeared. You have two components there, sorry, two vectors. Vector A here, and that vector A is I minus j. And then the second vector you have, it is 3i plus 2j. These are two vectors you have. What is the angle between the two vectors? Okay, they're asking what is the angle between two vectors? And the vectors itself are given to us. Think about the dot product and the cross product, and let me know which product you are going to use out of those two in this situation.
Dot product.
Dot product, because dot product is
Easy.
So you know that A dot B is equal to AB cosine theta. So that is going to give me this answer here. A dot B is equal to AB cosine theta. So the aim is to determine this theta, but before that, I need to look for the magnitude of this. Means this is the X component square plus the Y component square. So this is definitely 2 square root out of that. And here again, I also need to determine the magnitude for the B. So once I determine this magnitude for the X and this magnitude for the, for the B, these I put here, and then I left with the dot product. Vector A and vector B, so I need to make the dot product. So I times I, that's going to give me 1, and 1 times 3 is 3. So I got the 3 from the first one, and then from the second one, J times J, dot J, so it's again 1. The negative sign is there, and 2, so minus 2 is coming from there. Okay, here this notation I times I, so times 3. So this is a little bit, this notation is misleading a little bit. Let me put the point here. just a dot. Okay. So this is 1 times 3 and 1 times 2. So once you know everything, the only unknown is the pi, and you repeat the same procedure in order to determine this. Okay. So with this, I'm going to stop this lecture. If you have any question for me, you can ask, because I have a couple of minutes, and after that, my second class begins. Uh, just give me a quick feedback. How was the assignment? How did you feel about the assignment? And what was the level of the assignment?
It was medium.
Okay.
Not too hard, not too easy.
Okay. Any other student, what they felt about the exam, the assignment?
Yes.
That's the median.
Okay. And how long on the average this assignment has taken from you? How many hours you spent on the average?
50 minutes.
Half an hour.
Half an hour?
Yes, half an hour.
45 minutes, yeah.
Okay, so means that it is not too bad if I keep giving you that kind of assignments, right?
I actually got a small question, that's why it was half an hour. Other students got long questions.
Okay. Yeah, because the questions levels are the same, the difficulty levels of the questions are the same, but the components and the questions are going to be different a little bit. So the time from the 30 minutes to 1 hour, it will change. So who knows, next time you may get a question on which you may spend 1 hour and the other student may spend half an hour.
So this level of how hard it is very good. It's not too hard, not too easy.
Yeah, so that's I'm targeting the medium level for you guys, so that I want you to pick up at that level. And then if some students were looking for a little bit more interesting questions, so I can specifically assign some practice questions only to those students if they need more practice.
Doctor,
So this,
how
yes.
can I know mistake?
I will definitely discuss this, and it would be much easier for me as well as understandable for you if we keep discussing these assignments during our office hours. So I will be showing you the solutions and everything going step by step. If you have any problem, then we can resolve it. If you deserve any more points, then I can provide you points right away. So all the assignments will be going in that method that what I given you. So the next assignment also will happen in this week in chapter 3. And regarding the quizzes, I'm also will be giving you quizzes, but instead of on the recitation days, this next quiz will be again on the Tuesday. Okay, so the same day on which we has taken at the end of the class for 10 minutes. And this quiz will be again in the, this quiz will be this time on the Wiley Plus. Okay.
It's this Tuesday?
What is that?
This Tuesday?
Tuesday quiz is in the last chapter. Okay. Quiz is in the last chapter.
Chapter 2.
Chapter 2. But the assignment which I will be giving you probably that will appear to you on Wednesday. So that will be in the vector chapter. So always the method will be the assignment will come first, so that you can do your practice and familiarize yourself with the environment. And then after that, I will be giving you a quiz in the following week, so that you can do better in the quizzes.
Doctor.
Yes.
I have suggestion.
Yes.
The answer, can you make like flexibility, because